What's up, guys? Today we're going to be looking at inscribed angles. So what is an inscribed angle? Remember the word inscribed means inside. It kind of sounds the same. So an angle whose vertex is on the circle and whose sides are chords of the circle is an inscribed angle. The arc inside of an inscribed angle is called the intercepted arc. So an inscribed angle is an angle inside of a circle where the vertex is on the edge of the circle as well. Remember, a central angle comes from the center. An inscribed angle comes from a point on the circle. So the arc that it crosses, it intersects, that's the intercepted arc right there. Okay, so the interesting thing about an inscribed angle is exactly half the arc that it intercepts. So that is what you need to remember. So if they ask us what's the measure of angle ABD, notice the arc that it intersects is 124 degrees, so it's going to be exactly half of that. This angle would be 63 degrees. They ask us to find the measure of arc EFG. Well, if the angle is half the arc, then the arc would be twice the angle, right? So arc EFG, so the angle that makes it is 90, so the arc would be double that, 180. Find the measure of angle T and angle R. So angle T goes to an arc that is 66 degrees, so it would be half of that, 33. Angle R goes to that same arc. It would be 33 degrees. That's actually one of our theorems down below. We'll talk about it in just a second. Find A and B. A is an arc, B is an angle. Okay, let's see. How can we do this? Lots of stuff going on here. Okay. Oh, here we go. We've got a 60-degree angle right there. You probably spotted it quicker than I did. I'm a little slow today, I guess. That 60-degree angle makes that arc. Remember, the angle is half the arc, so the arc would be twice the angle. So A would be 120. And then to get B, B's angle intercepts this whole arc. That whole arc together would be 150, so the angle is exactly half that. B would be 75. Okay, angle A, notice we've got a diameter. It's always going to be 90 degrees because the diameter is 180, so it's half that. Right? It's half the circle, 180 degrees. Okay, find all four angles here. Okay, so let's look at angle A first. Angle A goes it goes from there to there. So it uses these two arcs together. So a total of 190. So half of that would be 95. B goes from there to there. So put those together, you've got 154. Half of 154 is 77. Angle C goes from here to there. So put those together, you've got 170. Half of 170 is 85. And then finally, angle D goes from A to C. So put those together, 206 divided by 2, 103. So there you go. Interesting stuff. Okay, so here is kind of what I was alluding to earlier. Number 3 is a good example of this first corollary. It says two inscribed angles that intercept the same arc are going to be congruent. So notice angle A goes to that pink arc, angle B goes to that pink arc. They would be congruent angles, and we showed that here. Angle T goes to this bottom arc, angle R goes to this bottom arc, and both of those angles were congruent because they intercept the same arc. Number 5 shows this corollary. A semicircle is always going to be a right angle. An angle that goes to a semicircle is a right angle. Well, we did the opposite of that. We had a diameter. So, yeah, I guess we did the same thing. Yeah, same thing. And then this one says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So let's look at number 6 for that. Opposite angles, 103 and 77. Those are supplementary because they add up to 180. 95 and 85. Those are supplementary because they add up to 180. So as long as it's a quadrilateral inside of a circle, opposite angles will always add up to 180. So we can use those properties here. Find each numbered angle. So angle 1, they give you some information you don't really need. Notice we are going to a diameter. So it's always going to be 90 degrees when the angle goes to a diameter, because a diameter is half the circle. It would be 180 for that total arc. Number 8 here, we're looking for angle 2. Again, they give us information that we don't care about. We don't care about that 70. It's not important. Notice this angle goes to this arc right here. And angle 2 also goes to the same arc. So since those two angles go to the same arc, those two angles have to be congruent. Angle 2 also has to be 38 degrees. Okay, number 9. Okay, this is nice because notice we've got a diameter in there. So that means angle 1 is 90 and angle 3 is also 90. Okay, and then all I have to do is figure out one of the other two, and the other one has to be its supplement. So look, angle 4, we have its whole arc, right? Angle 4 goes from here down to there. Add those together and you have 140. So angle 4 is half that. It would be 70. So that means angle 2 has to be its supplement. So what would it be to make it add up to 180? Well, 180 minus 70 gives you 110 left over. And there's all 4 angles of that problem. Okay, the last one, last objective, find the measure of an angle formed by a tangent in a chord. Okay, so we're going to have a tangent. Remember, a tangent is a line or a ray or anything that intersects a circle at exactly one point, and it's got to be outside of the circle. So it is very similar. If you have a tangent in a chord, the angle is going to still be half of the arc that it intercepts. Okay, so it says in this diagram, line SR is tangent to the circle at point Q. If the measure of arc PMQ is 212, let's fill that in. What is the measure of angle 1 and the measure of angle 2? Okay, so again, a tangent in a chord where it is going to be, the angle is going to be half the arc. So if this arc is 212, the other half of that would be 106. So that's angle 2. And then angle 1 is easy to find because it's a linear pair with angle 2, so it's got to be the leftover 74. You could also figure out what this arc is because it's got to be the other piece of 316 divided by 2, but that's more work, so don't make more work for yourself. All right, number 2 here, last one. It says segment KJ is tangent to circle O. What are the values of X and Y? They give us a hint. The inscribed angle, angle Q, and the angle formed by the tangent and chord, angle KJL, intercept the same arc. So that's a big hint there. Okay, so angle Q and the angle formed by the tangent and the chord, angle KJL, intercept the same arc. So notice that. So since this arc here is, or this angle is 35, the arc that it intersects would have to be double that. It would be 70. Now this one, that's tricky. That is tricky right there. So this angle intercepts the same arc. See that? That means that angle has to also be 35. So angle KJL, which by the way is X, so that's what we're trying to find. X also would be 35. Okay. So if that angle is 35, how do we find Y? Oh, look at that. I noticed something. Notice this is a diameter. Do you see that? QL is a diameter. So that means this whole half of the circle has to be 180. Or actually, that really means that this is 90 degrees there because it's half the circle. So 90 and 35 makes 125. What's the leftover for that triangle? 135 from 180 is 45. Okay, so those can be a little tricky, so just, pay attention to what's happening there. Let me know if you need any help with anything. I'll be glad to help you out. Just reach out. Good luck, guys. Have fun on the My Math Lab assignment.